Week 2, Installing Docker. System requirements. The system requirements for installing Docker can vary depending on the operating system and version of Docker you are using. Here are the general system requirements for Docker. Operating system. Docker can be installed on Windows, Linux, and macOS operating systems. Memory. Docker requires at least 2 GB of memory, but it is recommended to have at least 4 GB of memory for optimal performance. Storage. Docker requires a minimum of 20 GB of free disk space for installation and container images. It is recommended to have more disk space for storing container data and images. Note that these are general system requirements and may vary depending on the specific use case and workload. It is recommended to refer to the official Docker documentation for detailed system requirements for your specific operating system and version of Docker. Installing Docker on Linux, Windows, and macOS. Here are the general steps for installing Docker on Linux, Windows, and macOS. Linux. 1. Update the package index. 2. Add Docker's official GPG key. 3. Use the following command to set up the stable repository. 4. Update the package index again. 5. Install Docker Engine. 6. Verify that Docker Engine is installed correctly by running the Hello World image. Windows. 1. Download the Docker Desktop installer from the Docker website. 2. Double-click the installer to run it. 3. Follow the prompts in the installer to complete the installation. 4. After installation, Docker Desktop starts automatically. 5. Verify that Docker Desktop is installed correctly by running the Hello World image in a PowerShell or command prompt window. macOS. 1. Download the Docker Desktop installer from the Docker website. 2. Double-click the installer to run it. 3. Follow the prompts in the installer to complete the installation. 4. After installation, Docker Desktop starts automatically. 5. Verify that Docker Desktop is installed correctly by running the Hello World image in a terminal window. Configuring Docker. After installing Docker, there are some basic configurations that you can perform to optimize the usage of Docker. Here are some important configurations. 1. Configuring Docker to start at boot. To configure Docker to start automatically at boot. 2. Allowing non-root users to run Docker. By default, only the root user can run Docker commands. However, you can add a non-root user to the Docker group to allow them to run Docker commands. Note that you will need to log out and log back in for the changes to take effect. 3. Configuring Docker network settings. Docker uses a default network bridge to connect containers. However, you can create custom networks and configure network settings using the Docker network command. 4. Configuring Docker storage options. Docker stores container data and images in the default storage driver, which may not be optimal for your use case. You can configure Docker storage options using the Docker storage command to use a different storage driver or adjust storage settings. Overall, these configurations can help optimize the usage of Docker for your specific use case and workload. You can refer to the official Docker documentation for more detailed information on configuring Docker. Week 3, Docker Networking. Docker networking is a feature in Docker that enables containers to communicate with each other and with the host system, allowing developers to build complex, multi-container applications. It provides different types of networks, such as bridge, host, overlay, and MACLAN, and offers a command line interface to create, manage, and configure networks. Docker networking concepts. Here are some key Docker networking concepts. 1. Network. A Docker network is a virtual network that allows communication between containers and the host system. Each container can be connected to one or more networks. 2. Network driver. A network driver is a plugin that provides a specific networking functionality to Docker. Docker provides several built-in network drivers, such as bridge, host, overlay, and MACLAN, and allows users to create custom network drivers. 3. Network namespace. A network namespace is a Linux kernel feature that provides network isolation. Each container has its own network namespace, which allows it to have its own network interfaces, IP addresses, and routing tables. 4. IP address. Each container connected to a network is assigned an IP address from the network's address range. This IP address allows containers to communicate with each other. These are some basic concepts of Docker networking. Docker networking offers many more features and configurations, such as network security and network aliases, which provide additional flexibility and functionality. Configuring network services. In Docker, you can configure network services using the container's command line interface or through a Docker Compose file. Here are the basic steps to configure network services in Docker. Choose a network driver. Docker supports several network drivers, such as Bridge, Host, Overlay, and Maclin. You can choose the appropriate driver for your use case, depending on your network requirements. Create a network. Use the Docker network create command to create a network. You can specify the driver and other options, such as subnet and gateway, to configure the network. Connect the container to the network. Use the network option when running the container to connect it to the network you created. Configure the container's network settings. You can use the container's command line interface to configure its network settings, such as IP address and DNS server. Exposing container ports. In Docker, you can expose container ports to the host system using port mapping. Port mapping maps a port on the host system to a port on the container, allowing external processes to access the container's network services. Here are the basic steps to expose container ports in Docker. 1. Choose the ports to expose. Identify the ports that your container needs to expose to the host system. 2. Specify the port mapping. Use the P or publish option when running the container to specify the port mapping. The syntax for port mapping is host port, container port. For example, to map port 80 on the host system to port 8080 in the container, you would use the option P80:8080. 3. Test the port mapping. Verify that the container's network service is accessible from the host system by connecting to the mapped port.
Thanks for watching. For more information, like, comment, and subscribe our channel.